Hello everyone, this is Ahmaduddin, and today I'm going to discuss what is self-supervised learning. This is the first video of a series of multiple videos discussing the self-supervised learning. First thing is I'm going to assume that you already have a background about what is deep learning, what are the architectures like CNN, RNN, what are the training strategies like backpropagation, initialization, batch norm, and so on. This stuff, I'm not going to discuss those in these videos, but I'm assuming that you already know about these. So initially, I'm going to discuss supervised learning. And in supervised learning, we assume that we have some data that consists of samples and their associated labels. Our aim is to minimize a loss function based on these labels. So for example, here we have this boat image, and our goal is to classify the boat images from the dogs, cats, birds. We have this CNN network. We feed the network with the images, like this case, for example, and ask it to provide some predictions. But the supervised learning has some limitations. The first is that it depends on labeled data, and not just labeled data. We need a large amount of labeled data so that the model can train efficiently. Actually, collecting these data and labeling them afterwards can be very time consuming, can be very expensive. And in some applications, like medical applications, for example, it requires specialized persons to make this labeling. The second limitation is limited generalization. And because deep learning models are usually trained on specific data sets, these sometimes may not generalize well to new unseen domains. This is particularly true if the training data is biased or is not representative very well to the true population. The third one is the overfitting, and this is a result from the two previous problems. And the model may overfit to the training data if they are too small, and this will not make the model generalize well to the new data. The last thing is that it can be affected with the noisy samples. In this case, the training data can contain some errors or outliers that are not representative to the true population, and hence the model may learn to associate incorrect labels having these certain patterns of data. And this, of course, reduces the overall accuracy and the reliability of the model. So how can we solve these issues? Again, these are the main four problems. And the first is that we need a lot of labels. Then we can generate or label more data. It has limited generalization. Again, train on more data, but from maybe various domains. We have overfitting problem. Again, generate or label more data. We have noisy data. Try to improve the quality of labels. So we can see that all these problems all revolve around the problem of having a lot of labels and having good quality labels and maybe some generalized data from more domains. These again are very time consuming. Usually they require a lot of effort, and this may not be viable in many domains. So that's why we came to self-supervised learning. So self-supervised learning is the best solution if you have a scenario where we have it's difficult to do data annotations and you only have some few labeled samples. But also you have a lot of unlabeled samples. The current research showed that besides solving the labeling issue, self-supervised learning can help to learn more general representations from data because they are not associated to the true labels. Make the model robust against the data imbalance issue. And again, you guessed it, yes, because we are not associating to the labels itself. Improve the model transferability over different domains. Yeah, and this is because we do not, again, learn on these specific labels. We learn some general representations that can generalize to other domains that may have some specific features, but again, sharing similar representations from our domain. So what is self-supervised learning? Self-supervised learning is all about finding a new task that we call a pretext task. And this task can help the model to learn useful representations from unlabeled data, thus improve the model performance on the original task, which we call the downstream task. Self-supervised learning can be performed with the supervised learning objectives like classification, but we are not going to classify with the true labels. We can generate labels for these pretext tasks automatically for free. That does not require any annotations or any effort for annotating the true labels. What are examples of these? So the first example is solving the jigsaw puzzle. In this task, we have this unlabeled image, like this tiger, for example. So the downstream task can be anything like, for example, classifying tigers and lions and cats, for example. But since we do not have the true labels for tigers and lions and cats, we try to learn from the unlabeled data. So what did the authors of this paper do? They split the image into some patches, then shuffled the patches, and given the true order and the new shuffled patches, we try to train the model how to reorder the shuffled patches. So as you can see, this task does not require any label, and it will help the model to learn more about what makes the tiger tiger, what makes the lion, what are the features of the lion, what are the features of the tiger. It can help the model to learn these representations without being biased to the specific label itself. Another example here is to classify image rotation. So we have the image here. The authors propose to rotate the image with different angles, like 0 degree, 90 degree, 180, and 270. And we associate a pseudo label to each one. So rotating with 0 degree, it is associated with a label of 0, and with 90 degree, a label of 1, and so on. Now the task will become just to train the model to predict the true class of the rotation angle. In this way, also again, we help the model to learn representations about the image itself, and also we do not require any true label for the image. So that's it for this video. We tried to provide a general overview about self-supervised learning and the tasks, but stay tuned for a next video that describes more details about self-supervised learning.